Welcome to all students in this our topic. Now students, we have completed the electrochemistry chapter in the previous lecture, and in our today's lecture we are going to learn a new chapter, that is chemical kinetics. Student, before going to this chapter we should know some basic concepts related to this chapter. First of all, the practical which you have carried out for chemical kinetics, which gives us the basic knowledge of this chapter. Now, what is meant by chemical kinetics? That now we are going to learn first. Chemical kinetics is the part of chemical science dealing with the study of rates of chemical reactions and the factors which affect on the rate of reactions. And this will gives us the important part of the chemical reaction which is taking place at a particular moment. Means, suppose student, if we have a plus b gives c, here a plus b, both these are, we are calling it as reactants. When they combine, they form the product c. In this case, the reactants A and B, when they are reacting together, means actually they are converting it into the product. While converting it into the product, the reactions which is taking place, which will gives us the very important knowledge, means how much reactant will converted into how much percentage of product. This is a very important knowledge for whether the progress of that reaction is taking place in how much percentage. So the next part will comes, that is reaction rates. Rate of chemical reaction is nothing but the change in concentration of a reactant or product with time. That already I have explained now. The progress of that reaction means how much changes in concentration of reactant will take place. That part will decide the rate of chemical reaction. So we have written like this: rate of chemical reaction is nothing but change in concentration of a reactant or product with time. Now we are measuring concentration in mole per liter and with respect to time. Rate of reaction is nothing but the change in concentration divided by the change in time. Now students, by considering a particular reaction, we will understand what is meant by chemical kinetics. Students, this is the simplest reaction. A converts into product B, that is A is reactant and B is the product. While converting it into the product B, we have to write its rate, and rate already we have explained. Rate is nothing but the change in concentration of reactant with respect to the time, that is delta T. Now students, why the rate law we have written like this? Means why there is a minus sign is we have taken here. The reason is that if we consider the reactants, the concentration of reactants in the progress of reaction will decrease, and the product, the concentration of product with respect to the time, with the progress of time, it will increase. So this is the reason why we have written for reactants minus sign, and for products we have taken as it is the plus sign. Now delta concentration of A is nothing but the change in concentration of A over the time period delta T, and same thing we for the B we have written change in concentration of B over the time period delta T, and its reason we have written why we have taken the minus sign at the in front of delta A we have written here. Students, now we will learn the progress of that reaction we have seen in the previous slide. Students, look at this, the time as well as the progress of that reaction we have taken simultaneously here. At the start of the reaction, the concentration of A is nothing but 100%. But if the time progresses, in the second box you will notice that some of the reactant molecules gets converted into the B, that is product. Red dots are now going to increase. But in third box, again what happened? B, that is molecules of B gets increased, which means that the concentration of B is now going to be increased and the concentration of A is now going to be decreased. So this is the change that we have noticed throughout the reaction. But if you look at in the last box, you will notice that maximum percentage of product gets formed from the reactant. So this is nothing but the rate of the reaction minus delta concentration of A, that is reactant, divided by its corresponding change in time. And for the above reaction, the corresponding plot also we have drawn here, number of molecules versus the change in time, which tells us that how much that reactants gets converted into the product molecules and at what time, what is the progress of that reaction, that also we can conclude from this graph. Now we are going to learn the rate expression. We know that how to work out the rate of the reaction, but that doesn't tells us if the all the reactants make the same contribution to the overall reaction. At that time what we have to do is that's where the rate expression comes in. Means we should take the help of the rate expression. By using this rate expression, we can calculate the reaction at that particular moment. Look at this reaction x plus y, which gives z. Now here x may make more contribution to the rate of the reaction than that of the y. Or if we consider x may make no contribution to the rate of the reaction, inside it depends on, instead of that it will depends on y. The only way to find this out is through the experimentation. Now throughout that experimentation we can find the corresponding rate expression for that particular reaction. So students, this is what the introduction of this chapter. In our today's lecture we will learn we have learned what is meant by the chemical kinetics and its corresponding progress of reaction, or the you can say the rate, how to determine the rate of that expression. So this is all about in our today's lecture. Thank you very much.